These are not really transducers, but that's what we went ahead and going to cover the chapter so we can get into that and understand that. So this is the picture of our photoresistor or our photocells, right? And all I'm going to do is I'm going to come up here and zoom in on this. Those are pixels. So a pixel is a group of triads that all have the same color. Of course, I blew the pic, and that's basically all you do when you zoom in on these digital pictures. You just make the pixels bigger. And if you zoom in too far, eventually you're going to see squares. So that's all a pixel is, just a square. And all the triads within this square are all the same color. So my eyes see this as gray, right? But we understand that's still red, green, blue, and black that's making up those colors, which is pretty interesting. So every once in a while, in TV, we call it pixelation, where pixels actually drop out. And you'll see these squares start popping up on your screen because they're losing pixels, right, in the transmission. But pixel is nothing but a square. So this is digital. These little triads are either what? They're either off or they're on. Same way, exactly the same way. It uses pixels. So it's got those. It works almost identical to one of these, except the backlight is extremely bright, and then they shoot it through an LCD screen, a liquid crystal. So these work on liquid crystal. They work just like these monitors do, exactly, except they use a high intensity light, and of course they got to cool the liquid crystal, so you have fans and everything blowing inside of them. But that's exactly the way these things work. Yeah, but it turns on black. It's got a when the liquid crystal comes off, it blocks the light, which gives us black. Are we okay? And this is from Wiki that shows you the triads inside a flat screen TV or a what we call liquid crystal. And that's covered in chapter 15. It's not actually part of the transducers. So when you see these big old signs up on the screen, these are literally LEDs. LEDs has usually LEDs didn't put out a lot of lumens, but now we can get them. The LEDs we make now can be very bright. Red, green, blue, and black. That's all there are. So they have these arrays here, and how they come up geometrically, you come up and get that. But see, red, green, blue, red, green, blue. See the triads right here. And then they did do what? They turn them on, or turn them on, or turn them off. And when you're back far enough, you ever get close to one of these things, you can actually start seeing the little dots on some of these on the side of the road. It's just that you're back so far, your eyes blend all this together. And things are nothing but, basically, they're nothing but uh, personal computer screens showing a PowerPoint slide. That's all they're doing. So I could do the same thing up here. So they'll come up there. A lot of times they got Wi-Fi or Bluetooth on them, and they'll pull their truck right up there and they'll reprogram the PowerPoint slide up there, which is pretty neat. Photodiodes. These are diodes. By the way, notice in these things right here. We get down in here. It says they're what? Infrared. You ever run into these things before? So infrared is a light that has basically it's almost one color, but it's out of the light spectrum. So did I kill my camera? I didn't see it up there. It's okay. I want to bring up this other camera anyway. Hopefully the other one's not running. If it's on, it's going to turn out to be black. This camera won't pick it up, but so I'm going to get this away. So I come over and do this. Can y'all see this thing? Does it do anything? Huh? Huh? I'm going to come over and put it on this camera. You press a button. I lie. I saw it flashing a while ago. Darn it. Wonder why it's not picking it up now. This is infrared. No. This camera over here definitely won't pick it up. Only some cameras, they do it when they do light adjust. And it's working, by the way. Well, guys, I was going to show y'all that, but for some reason the camera's not picking it up now. That's why I had this other camera hooked up here, because it would show the flashing. And what they do is, there it is. But these are the wavelengths we can't see. So this is infrared, right? This is what the camera sees. And so what happens when I press this, can you see it flashing? So what it does is it flashes a pattern. And then this guy right here has got a photo detector on there that picks up those flashes, and it picks up that pattern of the flashes and defines that as a what? As a certain control on there. The only one it picks up is the number 1 key. That's the problem. But they're all flashing, so they all flash a pattern, which is pretty neat. These are infrared, so all your remotes that you have on your, like for your TV and your cable box and all that stuff at home, those are infrared. So you can put them at your face, you can't see anything happening, but it's still flashing those lights. Well, if it's flashing, if I've got an LED that's flashing, then I've got to have a device on the other side that receives light, right? You understand? And one of the devices that we use is something called a photodiode. So notice it's got the same symbol, but the arrows, photodiodes are put in the circuit reverse bias, kind of like a Zener. And what they do is they change the breakover. The breakover voltage changes with light. So these things would be out there. Photodiode would pick up those pulses. So they change their, and then of course we'd have to put it in a series resistor. So these are called photodiodes. We don't have any photodiodes, guys. So we have phototransistors. Photodiodes, once we look at a bipolar transistor, photodiodes are not used that much anymore because they were replaced by phototransistors, and we'll look at those later on. So what does a photodiode do? Well, a light emitting diode emits light. A photodiode receives light. Then we get into photoelectric sensors. We use these guys here a lot, especially in really clean environments. You won't see many of these things out at US Steel, but Mercedes, you're going to see tons of them because that's a very clean environment. These guys are what we call non-contact proximity sensors. Proximity sensors don't know it knows when it's at a position. And we use these things for all types of things. Now notice here we have a light source on one side. This is probably could be a light emitting diode, or it could be an infrared diode, right? You understand that. And then over here we've got some type of detector that detects that. That could be a photodiode, but odds are it's going to be a phototransistor, which basically serves the same function, but it's got a little more features than a photodiode. So what happens is when these boxes or the object comes up here, what does it do? So right now, this detector sees light. And when the box moves in front of it, what does it do? It blocks it. So every time a box comes through there, it's going to block the light. So they know the box. They don't know where the box is right here, but they do know where the box is when it gets in front of that light. They know the exact position of it. So we refer to those as proximity. Proximity sensors basically detects when something's at a certain point. We have a mechanical one I'll show y'all called a limit switch. It's not electronic, so we don't really teach that in solid state because it makes physical contact. So these are through the beam, if that makes sense. So the object moves through the beam. So the transmitter and receiver are on different sides. It shoots a beam across, and when the beam breaks that, it knows a part is present or an object is present. Everybody okay? That makes sense. The next one we have, we call it a retroreflective. Now, a retroreflector is a reflector that's made up of a lot of triangles. So if we looked at it from the top, it would look something like this. And then they have hundreds of them across here, or a lot of them. Now, what's nice about this is it has a tendency over a viewable angle to reflect back to the source. So that means these guys don't have to be lined up perfectly. If that was a mirror, if my mirror was off or it got knocked a little bit, well, what would happen with a mirror? Well, a mirror, if it got knocked a little bit and went out on a little different angle, then what we would do, it would reflect back. It wouldn't reflect back to the receiver anymore. So we don't use mirrors because mirrors in an environment, they're going to be vibrating and stuff like that. There's a retroreflector up on the moon. So they literally can measure the exact distance to the moon because how they do it? Well, they shoot that beam up there. And it don't have to be perfectly aligned. It's just got to be within a area or within a certain location. Retroreflectors. So these guys here shoot a beam back out. It reflects off the retroreflector and passes back. So it works like a through the beam, but a through the beam has the ability to be further apart, right? You understand? Does that make sense? We have several of these on the line over there, both lines. Then we have what we call a diffuse sensor. A diffuse sensor literally deals with reflective light. So it's not reflecting off a reflector, it's reflecting off the object itself. Now, the problem we have with these things is it's going to depend on the color, right? You understand that. By the way, photo detectors cannot see transparent things. So we would not use photo detectors to sense if there's a piece of glass out there. Because what does glass do? It's not going to reflect, it's just going to go through, right? You understand that? So if we're going to detect something that's transparent, then we're going to have to use another type of device, like an ultrasonic sensor or something like that. But a diffuse sensor actually looks at the amount of light that reflects back off the object, which is pretty neat. And diffused. Everybody okay on those? Interrupter. These are used to detect. These are through the beam, but they got their own name. These are basically a photodiode and a LED. One of them's labeled E for emitter, one of them's labeled D for detector. These are infrared, so you can't see these things working because you can't see infrared light, right? You understand? But these are technically nothing but through the beam. What you mean? No. hope not. No. Yeah, but what we're looking at is we're looking at this. All right, I'm sorry. Let me redo that. The resistors are external, by the way, so you have to put the resistors out there. So this is what we see. So this guy right here would be called the, this is called the emitter, not because of the transistor, because it's the emitter of what? Light. This over here would be called the detector. Now what they do is they'll come over here and they'll have a plus, and then they'll have a plus, and it's backwards on this side over here. So that's where you would hook the resistor to, right? You understand that? So if we look at this, one of them is going to be labeled E, and one of them is going to be labeled D. Now, how they detect it and how they emit it, we know they emit it with an LED. Normally, they detect it with this device right here. It's called a phototransistor, but it works just like a photodiode. It's just faster and has the ability to, we can do other things to it. I'll pass this around so y'all can see it. And we run into these all over the place. Very popular on printers. We'll show y'all on the manufacturing line over there. They use them to detect when one of the robots is at a certain location. This is right here. Can y'all see the D and the E on there? So this says D, this says E, this is plus, this is plus. That shows you how to hook it up. If you got the part number on it, you would look it up. I don't know if the part number's on here or not. Yeah, it is. To see what current is required and what voltage is required. If you don't know it, then you use around what? 2 volts at 15 milliamps. These are pretty straightforward, and that should be okay. But you should look up the data sheet and look up the VF, because you have to exceed the VF to turn it on, right? You understand? Then the current that's required to produce the lumens. And then, of course, you need to look at the reverse breakover. But the reverse breakover on these things are going to be very low. So we usually operate them in a DC circuit. We usually operate them so they're not going to be reverse bias or backwards. So this is called an optical interrupter, and you can see some type of blade is going to come in and insert through that hole, that slot right there, and it's going to detect what it is. So it's nothing but a through the beam detector, but they're called optical interrupters. Here you go, Mitchell. Huh? Yeah, but cameras are very, very expensive. And if you're going to if you want to see if something is at a certain spot, then you're going to use these guys. If you're going to figure out the orientation and how it's turned and everything like that, then odds are you're going to use a camera system. Camera systems are very expensive, and it took them a long time to be adopted because everything was there, because we didn't have the processing power to process them at a speed that was worth anything. Now they're extremely fast, and they will actually give you what? Not a position. They will give you a position, but they'll also give you the orientation of something. Outline the part to make sure it's I wish I could find out of that potato chip factory, or they've got one too that does cranberries. And what they'll do is they'll have a camera system up above it, and they'll shoot them things across a gap faster than you can see. And they've got hundreds of little air jets up there. And what they'll do if they see something that don't match their parameters, while the thing's in flight, it's actually flying across the gap, they'll take a little air pressure and pop it out and pop it down into a reject thing. It's amazing. And that's how fast these camera systems are now. They're really, really, really fast. This is liquid crystal, guys. This is pretty neat stuff. This is covered in this chapter. So we're going ahead and doing all of chapter 15, even though the only transducers in chapter 15 are optical transducers. This is called liquid crystal. Liquid crystal, I don't forgot what the crystal actually is, but it's really, really weird in that when you put AC across it, it's not current, it's just an AC voltage, but then the crystals will align in a straight line. Now what they do is they backlight these things, then they polarize it. So notice the light is polarized to one polarity, and then the lens is polarized to another. So what happens is that if we put AC across the crystal, they line up straight, the light follows it, it doesn't bend, and it's blocked by the other side. When they take the AC off, the crystal actually realigns into a helix or a curve. Now what happens is the light comes through, and the light actually follows the helix, and then it comes out the other side. Then up here we have a colored lens. What's three colored lenses we have? Red, green, and blue. So if they put AC across it, we see black. If they put AC across the crystal, we see whatever color lens it is, and that's the way liquid crystal works, which is really, really neat. Whoever figured this out? Yeah, in the garage, right? So these are these guys right here. So what you're doing is you see the lens. You don't see the helix, but it goes through a liquid crystal. Took them a long time to get this too. Originally it was in a pretty long tube, and it's like a red light. You know, if a red light's got a tube on the front, if you're not looking at it head on, you can't see it. So liquid crystal and they still do have what they call a viewable angle, which means if you get out of that angle, you can't even see your picture anymore. And this is still true now. So if you take and that's one thing I used to do when I was going to buy a TV, I would stand in front of it, and then then I go to the side, because a lot of people don't sit right in front of the TV. So the viewable angle is one of the specifications on an LCD screen that a lot of people don't pay any attention to. And that's it for this chapter. So that's everything they covered so that's chapter what? 8 and chapter 15. Y'all got any questions on that? The slides are not available? I know the lecture's not available. I took it out. I should have. The lecture's going to be available. Some of y'all didn't do the quizzes. What I'm going to do after class today is I'll make both the lectures and the quizzes available again. Y'all get 2 shots at that quiz, right? All I did was actually look at it for attendance. So I had to take it off because people could go out and take it before I did the attendance. So that's why I took those down at the end of class. On the semesters? Well, you are too. You've had sensors. Didn't you take the sensors class? Well, we only had one test. No, I'm sorry, we've had 2. What we'll probably do is we'll probably put the test off to Monday. Is that okay with everybody? Yeah, I meant to put the review up there while I was there, but we were so busy. We had 3 big presentations to do, and then Nancy ended up working on those most of the time. So there's a lot that I wanted to do from y'all that I just didn't get around to do it. Let's go over to the manufacturing lines and look at this stuff.